In class, we've written down these two laws, a to the power of 1 over s, we defined it with the s root of a, and in analogy, a to the power of r over s is the rth power of the s root of a, or vice versa, the s root of the a to the r power. Example, we can say 8 to the power of 1/3. Now, according to this definition, we can write as the third root of 8. Fine. So some of us know that this is a 2. The same with 9 raised to the power of over half. Just another way of writing this as the square root of 9. And if you want me to, I'll put a 2 up here. Though the convention is often to leave that number out if it is a 2, and that is a plus minus 3. Now let's recall the definition of that square root. How is it defined? It is simply the inverse of the square. Yeah, just don't forget that. The inverse of the square is the square root. So if I write down in an abstract manner, square root of y, equal to x, that means x is the number that if you square it, you get y. X squared equal to y. And this number 2 here, that's the exponent, and that is the number I should put up here. So in this case, that's what's called a square root, because it's in the inverse of the square. Now, it would be silly to have such a powerful concept as the inverse of a power just for the square. Imagine this entire law would hold only for the number for that particular exponent 2. Now, that's not the case. This is true for any integer power and, as we'll see soon, any fractional number too. So what if I drew a cube? Cube of edge size a. Cube means all edges are the same length. So there you go. And I'm defining every edge to be a. So a here, a. Okay. And now I told you the volume is of this cube would be 27 centimeter cubed. Centimeter cubed is a volume unit. We might remember from, and I'm asking you to find me the edge length. So what is a, given the volume? You might recall from geometry that the volume V is simply the edge length a cubed. Okay. Now V is given, so let's write this to be 27 centimeter cubed, and I want to find a. Now, how do I get rid of the cube of the exponent 3? Recall what we did here. How did you get from the right to the left? To find the inverse of the square, I apply the second root. So why don't we try to apply the third root on both sides? That leaves me on the left a cubed, third root cancels, so that would be a equal to third root of 27, and magically, look what happens to the unit. The centimeter cubed turns into just a centimeter, which it should, since it is an edge length. You see how that happens. The cube here and the cube there are cancelled by the third root. Now, which number, remember the definition of the cube root, is that number that if you raise it to the power of 3, you would be back at 27, and we know that is equal to 3. So a cube of volume 27 centimeter cubed must have an edge length of 3 centimeters. No sign ambiguity here because it's an odd power. Now this is one way of writing it. If you recall the other law that a to the r raised to the power of s, that we all agreed with that power was simply a to the r times s. The exponents multiply. If you remember this law and accept it for what it is, let me put a box around to show you sort of a side note, then you must see automatically that taking the third root, square root, is the same, since your goal is to eliminate the power of 3, as if I had said this. raised to the power, so let me put parentheses, raised to the power of 1/3, right? And why is that? Because if I apply this operation on both sides, I am left on the left side, this happens, a to the power of 3, and now raised to the power of 1/3. Wow, there it is. I apply this law, means I have to multiply these numbers, and by design the 3 cancels the 1/3 exactly. So there will be, let me spell it out, a to the 3 times 1/3 equal to, and that's all there's to. So fractional powers, the ones that have a numerator of 1, are the same as saying I'm taking the nth root or the third root here, and if there's a numerator different from 1, that numerator then acts as another exponent on top of the square root. I hope this was useful. See you next week.